Yeah, thanks for having me. Great to be here. So let me maybe give you a little bit of background. So I'm in the Department of Integrative Biology. I'm a computational biologist. My lab studies protein and peptide engineering and microbes, bacteria, and viruses. We're not going to go into any of the biology here today, but part of my work is entirely computational. And so I do a lot of data science, data analysis, machine learning. And so my work has historically been close to software development and open source software development in particular. And I've also done a lot of work in data visualization, and that's where all the examples from today come from. So let's just start with some maybe quite obvious things, but that are worth noting. This doesn't advance. Okay, maybe when I click it does. Yes, so software engineering and maintenance is hard. And it's hard because you have to be able to do a lot of things. And many of the things you have to be able to do are maybe not immediately obvious. The first one is probably obvious. So the keyboard does not work to advance. Apparently not. Okay, so I'll use the mouse. You have to be able to write good software. Okay, great. That's the starting point. Most people think that's the end point, but it's not. That's just the basics. That's table stakes, right? Like once you can write good software, you can still like mess up in a million ways. And so let's go over like some of the other things that you need to be able to do. Well, you need to be able to write documentation and tutorials, because if your software is not documented, then nobody knows how to use it, or nobody wants to deal with it because it's just so cryptic, right? So you have to be able to do that. You have to manage releases. Somehow you have to release your software into the wild, and you have to do that in a way that like keeps your users happy rather than makes them upset, right? Like many skills related to that. Have to respond to and fix bug reports. If you have software that has some meaningful impact, then there will be users and they will find bugs and they will complain to you, and you need to deal with that. And that is very much social interaction, dealing with people that sometimes can be difficult. So difficult skill. Respond to user questions. It's sort of related, but not quite the same, right? Like a bug report ideally is a positive experience in the sense that like somebody used your software, they found a problem and they report the problem in a way that is constructive. User questions most of the time are not constructive, right? Your instinctive responses. Can you read the documentation? And I've been asked this 100 times. I've answered this 100 times. I'm so done with this question. That's like your instinctive response. And then you have to like breathe and you say, you know, this is on page 5 of the user manual. Please go there and read it. And that will be the answer to your question. And the list, oh, sorry, you should not break old features, right? If your software had a feature that has been around for 5 years, it shouldn't suddenly stop working because you don't care about it anymore. Your users probably still care. And it goes on and on and on, right? We could talk about marketing, social media presence, like how do your users even know that your software exists and so on. So it's a lot of skills. How can you learn all these skills, right? Okay, you can go to university and then maybe you learn to write good software, right? You go to a computer science program or so, that's presumably what they teach you. I'm not a computer scientist, so I don't know, but I would assume that's what they teach. But nobody really teaches the rest, right? And part of this is that it's not really something like responding to user queries. It's not something you can take a course in, right? I mean, maybe you could like take a workshop and people give you like best practices, do this, don't do this. But then it's just, you need to respond to 1,000 user queries and just learn how it feels. Like once you get the same question for the 300th time, how do you manage your emotions, right? And it can be very emotional, like when the questions are just really extremely not intelligent, let's say. So it's not something you can learn in a course. It's much more something that you need to learn by doing. It's almost like an apprenticeship model. Like there's topics or stuff that we learn in a university setting, and there's other things we don't, right? So plumbing, is not something you go to university, right? Plumbing is something you typically learn as an apprentice. It's not because it's not technically difficult or complicated job. I mean, plumbing is a fairly advanced job, but you really learn it by fixing 1,000 toilets, right? Once you fix 1,000 toilets, then maybe you're getting good at fixing toilets and you can be like left alone at a client and fix a toilet because you've seen any problem that can happen as you're fixing the toilet. So what's the best way to learn this? It's really to work with somebody who has fixed 1,000 toilets, and they let you do it and they check that you're doing the right thing, but you're in production, so to speak, right? You're actually at a client doing the work, even though maybe you're not quite ready for it. And so software development and maintenance, you kind of have to learn the same way, right? You have to learn it by doing, which means working on open source projects. Why open source? Well, you can work on closed source projects, but unless you work in a company, chances are if your software is closed source, nobody's going to use it. And so you're just not going to get the experience. So, okay, let's say I've convinced you, you say, yeah, I need to work on open source projects just to learn, just to gain the experience, right? Even if eventually you want to just be a software engineer at a company and like you don't really care about whether your actual work product is open or not. At the learning stage, it's just, you will learn much more if it's open. So let's say you've decided that you can write your own open source or like develop your own open source projects without coordinating with anybody, right? And so I've done this a lot. I have some examples here. This was one of the first. So everything I will be talking about today is R packages. It's fine. Who is using R here? Oh, okay, most of you. For those of you who are not using R, it doesn't matter, right? Everything I'm saying applies more or less the same if you're working with Python or if you're working with JavaScript or you're working with Rust. It's all the same, really. But I'm mostly working with R and I'm working in the data visualization space. And so this was the date they're published. That's just when the latest version was published. Like this was actually one of the first packages that I released that solved some problems that I had in the data visualization space. And since I've like done a couple more, and I've learned a lot, but really like I've learned nowhere near as much as actually working on the major project, which in my case was ggplot. So who is using ggplot? Most of you, okay, or maybe half. So ggplot is a data visualization software that is part of, or is written in R. It's very popular. Many research labs use it. Also quite widely used in industry. It's probably one of the like top 3 to 5 data visualization systems out there. And like over time, I've made it to be like a formal author on this package. So the rule in ggplot is generally that it's very much open to contribute, right? All of you could start contributing today to ggplot if you wanted to, and I'll towards the end talk a bit about like what are good ways to get started and maybe what are bad ways or not so good ways to get started. Then if you keep contributing and after a while you've made a meaningful amount of contributions to the software, then the formal maintainer, it used to be Hadley Wickham. Hadley Wickham. It is now Thomas Lynn Pedersen, who's really like in charge of the software. They at some point they may reach out to you and say, well, we think you're making good contributions. We're adding you as an, or we intend to add you as an author. But that's like really late stage, right? I mean, that's great if you get there, but that's not the primary goal. The primary goal, I think, is to gain experience. So just like a little bit of advertising. So I got this from the ggplot website. ggplot is used by hundreds of thousands of people to make millions of plots. I don't know how we know how many people actually use it. Millions of plots is probably true. I think I probably have personally made 10,000 or so. So you don't need users to create millions of plots. It has this ecosystem of extensions, which is really nice. This just an example of all the extensions. So 150 registered extensions. You don't have to register your extension with this website for it to exist. So this is nice because you can, like, if you're intimidated, but I mean, this is a large project with a large community, right? But you can get a lot done by starting to write extensions that you can just write on your own in the comfort of your own home, and you don't need to even tell anybody that you're doing it. So there's a lot you can do without needing to touch the main software code. But anyway, so let's go a little bit into why you learn much more working on a major project, right? What are the advantages? And I've already brought up some of those, but I just want to systematically go through them. So there we go. You're working alongside experienced developers, right? That's the plumbing example that I started from the beginning. You're working with people that have way more experience, way more knowledge than you have, and you will learn something. As long as you don't piss them off, that's really important. But that's sort of the fine line you need to march. And then the project may have conventions and processes that you never considered. Like when I had like successfully released popular packages by the time I really started getting to work with ggplot, and there was so much that I wasn't doing, right? That I was learning from like being in the process, and they told me, well, this is how we do it. This is how you also need to do it. I was like, okay, well, I guess I need to learn this. And I'll go through some of those examples. And then if you have more users, you have more activity on issue trackers and community boards, right? Like it's almost nothing is more frustrating than you've spent a year crafting your great own software and you releases and nobody uses it, right? Like actually having users that talk to you can be really motivating. And also oftentimes like ideas for new features come from the users, right? The users say, oh, why can't I do this and this and that? And then like your first reaction is, oh, because that's 5 weeks of my time to implement, right? And then you ponder it and you're, oh, yeah, but it's kind of a good idea. And then you do it. And you might not have done it if nobody had prompted you. More users, the stakes are higher, right? Which is a good thing and a bad thing. But like fundamentally, I think we all we want to do things that matter. And so if you do something for 10,000 people, that's just more exciting than doing something for 5 people. So it's the same idea, right? It's motivating to work on a project that matters to a large user base. Do I have one more point here? No. So what I've learned, things you're likely not doing, but probably should. And I'm just being a bit arrogant here. Like maybe you do everything that I'm going to go through. Great. If you are, you're in the wrong talk. Let's start with the first one, which let's just go there. Use version control. Who is regularly using version control? Who is not regularly using version control? Some people did not raise their hand. You either are using it or you're not using it, right? It's everybody needs to be raising their hand. Who is using version control regularly? Okay, who is not using it regularly? All the other hands need to go up. Yes, if you're not using it, I don't know what you're doing. Maybe it's completely irrelevant to your job, but you're not using it. Okay, maybe you're doing that already, right? So most people are doing it to some extent. So just for those of you who do not know what I'm talking about, version control just means as you develop your software, you maintain a complete record of everything you have done. Like the moment you make a change, you have some database essentially that records the change. So you can go back in time. You can say, what did the software look like on January 1st, 2023? And there's many reasons why that is important. Most importantly, like I had this feature that worked in January 1st, 2023, and today it doesn't work. So now we can look at what changed in the code and maybe figure out why the feature worked then and didn't work now. Right? And the screenshot is from GitHub, which is one of the main platforms that people use for version control. There's an underlying software called Git that is really doing all the heavy lifting. You can use Git without using GitHub. Like some people don't like GitHub. It's owned by Microsoft. It's like the corporate overlord. Maybe we don't want to use GitHub. I use it, but it's fine if you don't like it. Git is completely open source software. Anybody can use Git, and is probably today the best version control software that is available. Okay. So the reason why I'm starting with this is, so I'm running a research lab. I have students in my lab that write code, and I constantly have to fight with them over using version control. So that is just my lived experience, that people have difficulty with version control. And I'll just tell you some of the things that happen, and then you can reflect on yourself whether you're working like that or not. So I'll talk to a student and I'll say, okay, do you have a repository? So that's how we're restoring the code. Do you have a repository where you're storing the code that you're working on? And they say, yeah, I do. And then they show me something that they have done like yesterday. And I say, is that code in the repository? And they say, no. And that is completely the opposite of how you're supposed to work, right? Like when I write code, like I code for 20 minutes and I commit it to the repository, right? Like I commit constantly. My biggest paranoia is that I lose the code. And by committing it and sending it also to the centralized Microsoft GitHub servers, Microsoft has it now, right? Like it's their job to not lose it. It's no longer my job to not lose it. If you steal my laptop, don't steal my laptop. But if you steal my laptop, all my code is on GitHub, right? I will just get a new laptop and download the code and start. I have not lost more than a day of work generally. Or actually, that would be a lot already for me. So my biggest fear is losing the code. The student's biggest fear is committing code to the repository that will embarrass them. And so they do not commit until they feel it's ready to commit, because they're so embarrassed of the committing something that is wrong. And so that's totally counterproductive, because then they don't necessarily have a record of what they did. They always have, like, the real goal with the repository is the authoritative source of your work, right? So everything you do in the repository. The moment you make a change, you commit it to the repository, so there's a record that you have done this. Very commonly, what I see in my students is they have the repository here, and then they have like a separate work area where they're working, and it's separate from the repository. And then they copy things over when they feel it's ready to be copied over. And that's just really bad practice. And so what happens routinely, so most of what we do in my lab, we're not necessarily developing software. It's more, we're doing data analysis. And so we have little data analysis pipelines, and we also in the repository, we actually store our process data in the repository, and we store the figures in the repository, so that ideally, like the entire research project, we sort of treat it like a digital lab notebook, right? Where everything we do as we go. I know I'm sort of deviating a little bit from open source development, but in my mind, those are like, they're very close. They're maybe not exactly the same, very close. So we have a digital lab notebook. And what happens all the time is, so then a year later, I go back to a project that a student worked on, and I say, oh, I want to reproduce figure 3. Let me dig in and see where the code is for figure 3. And it's not there, right? There's code for figure 1 and code for figure 2 and code for figure 4, but figure 3 is not there. And then I go, what happened? Oh, I must have done it separately and I never committed, right? Happens all the time, all the time. So actually use version control, right? Not pretend you're using version control, actually do it. Okay, so once you're there, the next thing, so now we're moving more towards like you're actually professionally developing a project. You want to use branches and pull requests instead of committing straight to main. So main is the main, oh yeah, not good to explain a word with the same word, but it is like that is where the predominant code base lives, right? And so these circles are sort of states of the code. And so I had like maybe on Tuesday it looked like this, on Wednesday it looked like this, on Thursday it looked like this. And so we have this complete record, right? And so this going from here to here means I've just made a change directly to the code base, right? Which sometimes is fine, but most of the time, really what you want to do, and if you're working in a group of people on a larger project, you just have to, you essentially make a temporary copy of your code, you go over here, and now you work a little bit on, like, you're fixing a bug, for example. You're working on something in parallel to the main development, right? And then when you're ready, then you push it back into the main trunk. And maybe, like, this could be just one person, right? This could be the graph of one person. Like, on Monday, I start fixing this bug, but it's not quite ready yet. And then on Tuesday, I have an idea for a new feature, right? And so I do another branch and I start working on the feature. And that may take me a little longer until it's ready, right? In the meantime, I've merged the bug fix in, and then later I merge the feature. Okay, who has made a branch in Git? Okay, good. Who is using Git but has not made a branch? Okay, we have a good audience here. Like, maybe you're like in the wrong talk, as I said. When I started working on ggplot, I had never made a branch in Git. And so that was one of the first things that I had to learn. And it was very intimidating initially. And it's actually, like, once you understand how it works, it's very easy. But it's just like one of these additional things. And there's many of those additional things, right? And it's very easy to say, it's too much. I can't deal with this. I just commit straight to main. But in a large project, you just cannot. Like, you are not allowed to commit to main. Right? Like, only Thomas Lynn Patterson is allowed to commit straight to main. All the other, even formal developers, cannot do that. They have to create a feature or a bug fix branch, and then when it's ready, it gets merged in. And that's a somewhat formal process. And so that is called a pull request. And so as part of a pull request, so let's say I've made my bug fix or my feature development, then you want to have code review, right? Now, code review is something that if you're just a sole developer, you really can't do. But if you're working in a team, it's extremely useful. So I just I think this was like one of my first, I don't know, it may have not been the first, but like this was like a change that I wanted to make, like some feature I was developing. And so this is just a screenshot from GitHub. It has this ability where, so this was Hadley Wickham himself at the time. He went through all my changes. So this green here is a change that I made. And then he just wrote comments, right? Like, should this be a function, or like return a named list, whatever that is. Or like here, I can't see here what I did exactly, but like somehow I didn't use proper code formatting style, right? So code formatting, which I don't even have a single slide on, but like code formatting is one of those things that, like, if you are working in like a well-maintained high standards project, they drive you insane with little nitpicks about code formatting, right? There's a comma missing, there's a space missing after your comma between argument 1 and 2. We will not merge this code until you've added the space, right? Or like, this line is too long, break it into I'm really nitpicky about those things. It's actually rare for me to get that because I'm usually the one that like nitpicks. I find something every time somebody makes a pull request, I find something where I just don't like how they format it, right? And it's not subjective. Like I mean, this modern tidyverse style, there's a book, right, that Hadley wrote that this is how we format code, and you can read the entire book. Most people don't read the book, and therefore they don't know how to format the code. So obviously, if you're working on a strong team and you have like friendly maintainers that work with you, you learn a lot from them having review your code regularly, right? That's a really, I mean, it can be really frustrating. Like, you've like worked hard on your pull request and you feel, oh, it's ready to merge. And that's really only when the process starts, because now there's like 20 things that you need to change. You need to reformat the code. You haven't actually documented what you've done, so please write documentation for your new feature. Oh, by the way, we have a log of where we record all the features that we have made, so that with the next release, There is like somebody can go on, oh, this was done, this was done, this was done. You did not update that log, right? You have to do that. It's like so many things. And you really have to work in a team that forces you, that has high standard and forces you, because if you just do it on your own, you probably will just be lazy and not do some of this. Okay, extensive automated unit tests. Unit tests can be a real pain, but once you get used to them, they're also extremely comforting. So this is just a screenshot of ggplot running all the tests. There's a total of about 2,500 tests. So I ran this on my computer. You can see here there's like fail, warning, skip, and okay. Skip just means a particular test isn't run because I may have, I might have to install some additional libraries on my computer for the skip tests to run. Like ideally, we wouldn't want to skip any tests, but like that was just like 2 days ago. I haven't done a lot of ggplot development lately. I just downloaded the latest version and ran it, and that is what it looked like. So 100 tests were skipped, 2,440 passed, and none failed or none were warnings, right? And the whole thing takes about 31 seconds on my computer. So it's not a long time, but you have to kind of wait for this to finish. This is really comforting after a while. Like you're working on ggplot and you realize this is tens of thousands of lines of code and hundreds of thousands of users, and you're making a change. And how do you know that you're not just messing up somebody's plot, right? Like it's the code change that you made seems fine, but like you're only like interactively testing a few things, and maybe there's some weird use case that you're not aware of that is now going to break, right? And that happens all the time. But if those 2,500 tests pass, chances are you haven't messed up too bad, right? Most things will still work. And then also if like the tests pass and then you release the software and then like somebody starts screaming, well, then you know you need to write another test, right? Your test suite wasn't like sufficiently comprehensive. There was like some corner case that some user depends on and that you're not testing. So many of those tests are actually from like painful experience. We have broken this feature in the past, and now like we test for it so we don't accidentally break it again, right? I mean, sometimes you go, oh no, we really need to break this, and then you actually remove the test, and then you like advertise very clearly, sorry, going forward, this particular thing no longer works. We have changed this. That is a valid point that sometimes you get to in software development. But if you have hundreds of thousands of users, you mostly want to avoid this, right? Because like the vast majority of bug reports that we get by now is we release a new version of ggplot and somebody says, this code ran just fine until last week and now it doesn't run anymore. You guys messed up. Most of the time then it's, no, you messed up. You should have read the documentation and you would have known that your code was actually, it worked, but it wasn't like the way it should have been. And anyway, my point is that like these tests, once you have them, you need to run them regularly, but then it like you really get dependent on them in a way. Like once you have experienced this, okay, I made a change, all the tests run fine, or like I made a change and the test did not run fine. Oh, thank God it caught my mistake. Like once you experience this a couple of times, you really realize how important these tests are. And so related to that, so who is routinely writing unit tests? One person. Like I think like at the end, like has anybody raised their hand on every single point I made? Maybe not. Like have you raised your hand every time so far? Good. So you write unit tests. Nobody else is. You should write unit tests, right? Unit tests are so important. And there's a common misunderstanding about unit tests that I want to address quickly. Most unit tests, when you look at them, look extremely stupid and silly. And that is okay. And I'll show you what I mean. So so useful tests are much simpler than you may think. I went through the ggplot tests and I looked for one that maybe was easy to understand and also not too much setup code. But so this test, there will be a comment in a moment that says it just tests that ggplot works fine if you give it a data set that has no data. And so this is what we're doing here. This df0 is a data frame. It has these columns, MPG, WT, AM, and there's a reason why it has these columns, because it'll be mixed with the data frame in a moment that actually has data in those columns. But each of those columns is just is a numerical column with 0 data. So there's just no data, it's empty. And so then this is the test. Layers with empty data are silently omitted. So we want ggplot to be able to take an empty data frame and then just not do anything with it, right? And so this is the first example, empty data, no visible points. So we're giving it the empty data, and by the way, there's a space missing here, and it really is bugging me. I've been thinking whether I should put that in. Should look like this, right? This must be really old code. So we're giving ggplot an empty data frame, but then otherwise we pretend we're making a scatter plot, and then we're extracting so with this get layer data, you can extract the final data frame that ggplot has that it's using to actually construct the plot. And so that should again be empty, right? N row, number of rows is 0. It should not have any data in there. And so you might say, well, what is this testing? I mean, why wouldn't it do that? And so if you have that reaction, like that is a good test. Most tests are about this complexity, right? And I can tell you from painful experience, when you mess something up, a test like that suddenly no longer passes, right? Suddenly this data frame has data, and you're like, where did that come from? And then you track it down and, oh yeah, I forgot, yeah, okay. So most tests will look that simple. And we don't have just one, we have 4 here that basically all test the same, right? So this was, we give the whole of ggplot this empty data frame. The other thing we can do is we just give it to the points. And then it's the same thing. It should not have data in the final data frame. Or we can mix. So this is this motor cars data set, which has actually these columns. And so up to here, it's a regular scatter plot of this data set. And now we're adding an additional layer of points with an empty data frame. And then we want 2 layers where one has the actual data and the other has nothing. And then the final one is we should also be able to do that where we give ggplot a data frame, but then we're not using it. We're just making a layer of points without data. And so then that tests. So it's just 4 tests, right? To test this really simple concept of if you don't put data in, you don't get data out. Write those tests, right? And write tests that are that simple. Like the idea for unit tests, so there's the concept of unit tests and integration test. Integration test is you use the entire software as is, and it does the right thing, right? So in ggplot, an integration test would be, I'm making a plot, and then the plot looks the way that it's supposed to look. And we actually have automated tests for that also, where we actually store like output plots, and then as part of the tests, we're comparing whether those plots actually look correct. Those tests are tricky though, because like all that needs to happen is like there's a little change, like we change just like a little bit in the margin, like we make the margin a little wider, let's say, like for stylistic reasons, we feel we need slightly larger margins in our plots. All the visual tests now fail because nothing is in the right location, right? So visual tests that test the whole thing are a huge headache because they constantly fail, and it's almost always false positives. Almost always there's a tiny little thing that changed that doesn't actually affect the functioning of the software. So, and that I would say is more generally true for integration testing. When you do integration testing, you often get false positives where just, yeah, it fails, but for a completely trivial reason. These unit tests, they should never fail. You're actually testing very elementary parts of your code, almost like by a line basis that it does the right thing, and they should be obvious, they should feel trivial, and they should never fail. But if you have thousands of them, some of them will fail once you start developing, and that's a really good check for you. So do this, but so now you have the tests, you have to actually run them, right? It's not good enough to just have them. You also have to make sure that they get run all the time. And that is called continuous integration. Who is using continuous integration? Very good. Continuous integration means every time you make a change to your software repository, you automatically run the tests. So this is this is a screenshot from the GitHub user interface where when you have a pull request. So we see here, this is one that was merged, but normally we run the checks before we merge. And so you see in this tab here, checks. So these checks get automatically run every time. So let's say I want to fix a bug. Well, what is the workflow? I check out the code, I make a branch, I do my development, and now I feel I've fixed the bug. So now I do what is called a pull request. I basically tell GitHub, I have changes that I want to add to the code base. And so I create that, and then automatically all the checks get run on the code that I want to merge. And so the maintainer can immediately see, did the checks pass or not, right? And if the checks didn't pass, then it's back to me, why don't the checks not pass? Like, you should not make a pull request if the checks don't pass, because it means you did not run the checks, right? It can be more complicated though, because these are the checks that we run. So it's kind of difficult to take screenshots of everything that's happening, but like it said 13 checks, right? What are the checks? Well, for example, we're checking on Mac OS with the latest, so release means the latest R release. And we're checking on Windows with the latest R release. And we're checking on Windows with an older version of R, right? One that is outdated now, but it's still around. And then we check on Unix, on Ubuntu. It just doesn't really like to move. Maybe I can use my, no, it's really difficult. Okay. So Devil, we check on the development version of R, right? And something may break there. And then here you see on Linux, we have Devil, release, old rel 1, 2, 3, 4. So we're going 4 versions back in R to make sure that ggplot runs with all of those, right? So maybe the latest version of R is 4.3, but somebody out there is still running 3.5, which is 3 or 4 years old. Like, we don't want them to suddenly have ggplot breaking. Well, actually, I mean, there's a policy, like everything has policies, right? Like, this is the number of releases that posit the company that ultimately is developing ggplot that they support, right? They support the current release of R and the prior 4 versions. And so if you're more than 4 versions back on your system, then they say, well, if something breaks, sorry, you need to deal with it. It's not our problem. But if you're using a version that is 3 releases back, they promise that it'll still work, right? And so something that happens all the time, I don't have an example here, but like, you have fixed your bug and it works just fine on your machine, and then you commit it, and then it only breaks on Mac, right? And then you're like, I don't have a Mac. I don't even know how to debug this, right? Or for me, I'm a Mac person. For me, it's more like it breaks on Windows, right? And then I'm like, I don't know how to fix this. Or it breaks on the development version of R, right? You may not always have the latest development version on your machine, and so it may work just fine with the released version of R, but not the development version of R. So having all of, like I said earlier, with like all the tests, I said it's really comforting when all the tests pass. It's even more comforting when they pass on all the different architectures, because you could not have done that on your, right? Nobody has like a Mac and a Windows machine and like Ubuntu machine all at home and runs their tests on all of those, right? Like it's also like, it's really nice that GitHub does it. And I'm not going into how to set this up, like there's these GitHub workflows. It's actually really easy. If you just like Google continuous integration GitHub, you'll very quickly find how to do this. And there's basically recipes for how to set it up. If you're not using R, if you're using Python or anything else, there's recipes for that, right? It's very easy to set up. It's just one more of those things that if you're not in the habit of doing it, chances are you're not doing it. But it would take you half an hour to set it up, right? It's just out of, say, ignorance or like, let's say, lack of experience, lack of knowledge that this is something that you should be doing, and it's actually not that difficult to do. You're just not doing it. One of the first things, if I start a new project so I don't do this for my research work where I'm just like plotting some data or so, but if it's an actual software package, all of this is like the first thing that I do, like set up the framework, set up the unit testing framework, set up the continuous integration, and just use it from day one. There's another part to that I don't have a slide here that you can also do. I care less about that, but sometimes it's useful, which is coverage, where as you're running the tests, you keep track of which lines in your code base you have actually tested. And that would allow you to find, oh, I have like a block of code over here that is just never tested in my unit tests, right? Maybe you have an if-else statement and all your unit tests hit the if and never the else. And so then that might be a reason to write additional tests that explicitly test the else. It's useful, like if I were running a software company and I was selling a product, I would probably do that. In practice, I don't worry too much about it because you can have coverage and still you're not properly testing that code block. So coverage is a little bit of a false promise maybe. And on the other hand, like if you're really messing up, your users will complain, and then you add the tests that they complained about. And like over time, the lived coverage of what are actually the code blocks that people use on some level is more important than this like formal assessment of, oh, your tests have tested this and this. Like the coverage maps, like where sometimes I've been really annoyed with is like they like complain, oh, you're not testing this line of code. And I'm like, that's if false. Like I can never reach this block of code, right? I can literally not write a test that will test this block of code, but the coverage map doesn't know that and just complains that you don't have 100% coverage. Anyways, so continuous integration, really useful. If you've never used it, look into it. It's very easy to set up with GitHub. Sort of a paid feature, but I think if your code is open source, so if your repository is public, you get a certain number of hours a month of continuous integration for free, I think. Does anybody know that by any chance? Like it used to be really free, like everybody could just run as much continuous integration as they wanted. But if you think about it, there's a lot of compute that Microsoft spends every time we make a commit, right? In particular, because these are all virtual machines that need to get started. And sometimes like some of those run like half an hour because like you boot it up and you have to install all the software that you need before you can run the tests. So even if the tests only take a minute, the installing the machine can sometimes take a long time. And so, yeah, Microsoft spends a lot of compute resources on our continuous integration. So they are obviously want you to pay for that to some extent. All right, then let me just quickly check on time. So it's 11:15, maybe another 10 minutes or so. Have a formal release process, right? So we have a checklist. There we go. So GitHub allows you to make these checklists. And so Thomas, the current maintainer, when he makes a new release, he starts by just copying this checklist into an issue. And then as he does the things, he checks them off one by one. And so that prevents you from from forgetting something, right? Because as you see, there's a lot of things, and like it keeps going. Like I cut it off here as submit CRAN. That's technically where you've made the release, because now it's actually on the repository that everybody uses, but there's additional steps. And so these checklists, they tend to grow over time as your project gets more complex, right? So it's a really good idea to somewhere have this release checklist and that you use every time you release, rather than just doing it on the seat of your pants. Oh yeah, I need to update the website, I need to update the news and so on, and then you forget something. And then also set up a nice website. Who has a website for their code? Very good. And Rmix is really nice, but most, so there's a ggplot website. Most modern software development environments make it relatively nice. I'm pretty sure Python has a very good setup, and those are the two ecosystems that I use fairly frequently. So if you're writing an R package, which this is, then there is some code that you run, and it basically just takes all the information from your package and turns it into a website. So it's really easy to do, not a good reason not to do, right? Just like spend the additional half hour to set up a website. And then of course the website needs content. Maybe I need to be here for it to work. So you want all the code, you want reference documentation, right? That explains all the different functions and how they work. You want tutorials, like how, like for a user, it's generally not pleasant to start with the reference documentation. They need something simple where they can just like go through a few steps and have something working quickly. You may want to write more in-depth articles. So the example that I picked here, so ggplot has its extension system, so you may want to explain how that works. And so we're stuck now. Oh, okay, now this works. And blog posts are also a good idea. Okay, let me just finish up. So how do you get started, right? A couple of things that you can do. And I'm assuming most of you are intimidated just starting on a large famous project, right? And I was intimidated. Like I did a lot of stupid stuff in my own packages where I was working around limitations of ggplot, and it didn't even occur to me that I could just go and fix the limitations rather than working around them, right? Because I was intimidated, right? And at the time, I was an assistant professor, so like somewhat reasonably successful person in my career. I was not like a young graduate student. Maybe as a grad student, I would have been more daring. I don't know. But like, it's intimidating if there's like a widely used software package written by like the people that you look up to, the biggest names in the field. You don't necessarily feel comfortable going there and saying, hey, take my contributions, right? Again, like initially it didn't even occur to me that that was an option. So how do you get started? File bug reports, right? If you are using the software and you encounter issues, report those, right? And it's also good, like very easy to file ggplot bug reports because it's very welcoming. Very difficult to file R bug reports because they make it really difficult to file bug reports. So even though I use R all the time, I never file R bug reports because I don't want to deal with the hassle. So that is just like a community sort of temperature check. If the community makes it difficult to join, then maybe you don't want to join, or you really need to want to join then. Like join a community that is welcoming and makes it easy, I would say, certainly as a beginner. So file bug reports and see how that goes, right? Respond to bug reports and other user requests. And I have a few examples in a minute. Like we get, I would say for one useful bug report, we get probably at least 10 that are not useful. And they're not useful because either people misunderstand the system that they're using, or it's a duplicate. We already have gotten that bug report. We know it's a problem, but like the person filing did not bother to search for old versions. They just filed their report. They haven't read the manual, or they're just asking for user support, right? They just don't know how to use the system and they're asking questions, but that's really not what bug reports are for. So as a maintainer, you spend a lot of time doing all the stuff that really you don't want to do. And so if there's like people in the community that maybe are not current developers or maintainers, but they know how the software works and they respond to those bug reports, that's really helpful for you as the maintainer, right? Like I have a software, somebody files a stupid bug report. I'm like, oh, no, I need to deal with this. And then like some other person goes, hey, this was maybe the wrong question to ask, or this has already been asked. And I'm like, oh, I don't need to deal with it. Great. So it's a great way to basically get credibility in the eyes of the maintainers. Then you can file feature requests, right? I think like bug reports first, right? Like don't immediately go, oh, why don't you implement this and this and that? Like do that once you have a bit of credibility and you know that the maintainers know what you know and what you don't know. And then you can start fixing things, right? And start small, like can fix things in the documentation, right? Like this is a little awkwardly worded, or like a paragraph that describes this topic might be really useful. I've made one. Can we add this to the code base? It's a great way to start without, like, it's a low risk. Right? What's the worst thing that can happen if you mess something up in the documentation? Well, it was incomprehensible anyway. It's still incomprehensible, right? Like, can gain a lot of experience there. And then generally be active in the community, see how you can add value, and think about reducing rather than adding to maintainer workload, right? If what you do constantly means the maintainers need to do something, you may be annoying them and you may get a reputation of being that like annoying person that constantly knows everything better but never adds any value. Versus if you go and you actually like respond to bug reports that other people have filed, that's very simple tasks like, hey, this bug report was already filed 5 weeks ago, here's the duplicate. That is useful, right? Even if you don't have the ability to now close the bug report, the maintainer now can just close it, doesn't have to also write the explanation, right? And sometimes as a maintainer, like or as an active member in the community, I know this bug has been filed, but it might take me 10 minutes to find that, right? And so if somebody else does this for me, great. I didn't have to do that, right? And so I have 3 quick things that I want to go over that sort of show these interactions. So here's my first bug report to ggplot. The title, you may not make sense, but the dup access is a function, does not properly duplicate the access name. And then my, does it still work? Sort of. The following code should duplicate the x-axis, including the name. However, that doesn't happen. The name is not duplicated. And then I have 2 lines of code that show the example and the output, right? So note it reports one clear issue. The title states the problem, and it's 2 lines of code with output, right? That's a good bug report, right? That's very actionable. And maybe I don't remember what the response was here, but like there's no doubt about what is happening. There's not 100 lines of code. Like a bad bug report is somebody just pastes 100 lines of code and says, oh, download this data set from this website, install these 3 packages and run this 100 lines of code, and then you get an error message. Right? I'm like, no, I'm not doing that. Yeah. That is a bug report, right? 2 lines of code that have like isolated the issue and that I can run and immediately see, okay, can I fix this or not? Yeah. Most bug reports don't look like this, right? Most bug reports are like hundreds of lines of code and data sets that you need to download and so on, and nobody wants it. So here's like a recent one that is sort of like, it's actually not even that bad, but it's still pretty bad. Okay, scale shape manual doesn't work on DORP equals F. There's no DORP equals F, that's a typo, but anyway. And then if we read tips for a helpful bug report, if you have a question, please don't use this form, blah, blah, blah. The very bottom says, delete these instructions once you have read them. So when somebody files a bug report, we give them all these instructions because these are common things that people don't do. Well, this person obviously didn't read that. And then this is their bug report. Has 3 shape, but need to present 6. And then there's some code. Legend shows well on ggplot version 3.4, but not 3.5. So it's actually not even that terrible because this is actually a self-contained code example, but it does not show me the output under the 2 versions, right? So I, as the maintainer, now I read this and I say, okay, this may be valid, it may not, but I cannot in a minute immediately figure out what's going on here, right? If the person had just copied, like, this is the output in this version, this is the output in this version, they're not the same, which one is correct? I can immediately look at that, right? So now as like a volunteer could go in and run this code, make the 2 outputs and say, just basically clean it up, right? And say, okay, this is the issue, this is the output here, this is the output here, and then step back and let the maintainer figure out whether it's an actual bug or not, right? And then this is a different example, and I'm almost done. So this is actually very clear and comprehensible. I found what I believe is a problem with geom-text, and then they have a code example here and an output, and it turns out like this is actually a misunderstanding of how R works. This is standard R lazy evaluation. Geom point is exactly the same. So it's not a bug. It's just a misunderstanding of how the code works. And then I just close this because I can. But if I was a new volunteer, I mean, this would still contribute, right? This means the maintainer doesn't have to write this. So those are useful contributions that you can do to get like going with the project and get to know the people, get to become a member of the community. So pick a project and get started. And these are all the people that I have learned from working on ggplot. There's many others, but those are the main people that I really learned specific things. Okay, and I'm on time.
That's fantastic. Thank you so much. A great talk. We do have a little bit of time for questions if you have a few minutes.
I have time.
Okay, great. So yeah, I have a microphone. I can run it around the room here if anybody has questions that is here in person. I'll also take a look at our chat. If you do have any questions, feel free to put them in the chat here. I can relay those. So I have a few questions.
Okay.
Maybe I can kick it off.
Yeah.
So you were mentioning that people might be a little bit afraid to be pushing their code to the repository and afraid about how that might be viewed. And that's definitely something I felt myself when trying to get code ready to contribute and wondering, when should I be pushing this? I don't want to be embarrassing myself by pushing something that is not ready yet, or others might look and clearly identify some issues because I haven't had a chance to fully scan it and fix everything. Are there any negatives to that? If we're kind of taking that advice and let's say, all right, we're committing more frequently, we're pushing more frequently. Really, should we not be worried about that, or are there potential impacts that we should be trying to avoid?
No, there's really only one thing that you need to avoid, but like it's almost orthogonal. Sometimes you develop something where you have like a secret API key or something. You should absolutely never commit that to the repository, right? And so if you're like taking a shortcut and you just write the API key into your code because like you haven't, like you're just still even figuring out how this whole thing works and you don't yet have it properly set up where the API key is stored elsewhere, like committing that can cause real issues, right? Like up to like if you're working on a cryptocurrency project and you commit the private key to the repository, you may be losing billions of dollars, right? I mean, that has happened. So that is like a real issue. Like if there's like something that genuinely is like confidential and should not be public, anything else, I would say just get over it. I mean, you can go to all my Git repositories and like look at the first commits, and you know, some of them are stupid, silly, buggy, and that's just what it is. I would also say, you know, it's much more embarrassing to have the bad code still in 10 years later than have it in day one, right? Like I'm much more embarrassed, like my cowplot project that I developed early on, there's so many issues that like I would not do it that way today. And like from time to time, I'm like, oh, should I just rewrite everything? And then I'm like, first of all, it breaks all the backwards compatibility. People kind of rely on the broken use or broken implementation, and also would be so much work. Is it really worth it? Probably not. And then I don't. But that I find much more like personally much more embarrassing than like 10 years ago for like a 2-week period, there was like some code that was not very elegant. Right? I mean, just like, yeah, get over it and just commit so much that you don't think about it and nobody will ever find it because like, it's thousands of commits and nobody is going to go through that whole history ever.
Great, thank you for that perspective. Any other questions? Alex?
Yeah, thanks so much. It's that there was a lot shown about testing when releasing a new version. I'm wondering with something like ggplot, where there's so many other packages that rely on it, is there any sort of testing process before you release something to see if you're breaking a bunch of those external libraries that rely on ggplot before it's released?
Yes, it's a nightmare. Genuinely. So this is actually, so part of the reason why R generally works and Python doesn't, right? So you download an R package and it just works. You download a Python package and it breaks, right? That's just lived experience. The reason is that R is extremely picky about what they release in on the CRAN server. And actually to release a package on CRAN, before they release it, they actually test every downstream dependency against your new package. And if any downstream dependency breaks, they will not release your package. Which means in practice, you have to run this test first, which means if you have, actually, let me see if this works. Go back to the very beginning. Okay, this actually seems to be working. Where? Oh, I don't have the number of downstream dependencies. So actually this package, a third of all packages in CRAN depend on this package. Because it actually is a key, is a key feature for ggplot. It is the way that ggplot draws density plots, and so I wrote this at some point, and then like so a third of the packages in CRAN depend on ggplot, and then ggplot depends on this. So like there was a problem with this package a couple of years ago where it was actually only in the testing part, the package was working fine, but for some reason, like one of the many tests that they run no longer worked. And then CRAN has this policy that they threatened to remove the package. And so I was on vacation while they did that. And so then they threatened that they would shut down a third of CRAN because
including my package.
So CRAN sometimes takes it a little too far. But so that means like if you want to make a new release of something like this or of ggplot or whatever, you have thousands of packages that you need to test. And then inevitably, every time we make a new ggplot release, one of those packages will break, right? All our unit tests pass, but some downstream package breaks. And then it's sort of complicated. I mean, the R or the CRAN policy is if you inform people with like some lead time and then they don't take action, then it's their problem. But in practice, usually it's sort of a back and forth. You know, you kind of try to figure out what their problem is. And it's usually that they're misusing your code in some way. And then you try to negotiate with them and say, hey, and you're sort of fixing their code, right? It's one of the reasons why, like for me, now I have PTSD from releasing new R packages, right? Because when like Cowplot is old enough that it has a bunch of dependencies. DG Ridges, I think, also has a bunch of dependencies. Something breaks every time, right? First of all, like testing all these downstream packages, it runs for 5 hours, right? Because you're nodding. Have you experienced that?
Yeah, I try to make a commit to SF, and that's like 10 hours, and it's overnight.
Yeah, so it's very painful, right? But it's CRAN maybe is pushing it a bit too far, but that is what you need to do to have a software ecosystem that doesn't just constantly break. Right? You just constantly have to check everything against everything. And so, yes, we routinely, actually, it may be, it should be on the, where was the checklist that Thomas and Phyllis uses? This is the nightmare, right? This is where it checks all downstream dependencies and finds all the issues. Like, first of all, it is a huge amount of compute. You have thousands of packages that all individually need to be checked. Sometimes before you can check them, like they need to be installed and they need to be compiled. So just like the installation of some of those packages may take 20 minutes on a machine or so, right? And then you run the check on the old version of your package and on the new version of your package. And then it's like, if a problem was already there on the old version, then it's fine, we can ignore it. But if we have a new problem, then we need to figure out what happens, right? And so there's like, it takes a day or two to just run. And then you have thousands of reports that then you need to triage and you say, okay, here we have 20, they're all this one issue. We made this change in the code. Do we want to backtrack or do we want to forge ahead and talk to those 20 people, right? And then usually like the vast majority of issues you can like resolve pretty quickly. And then there's 2 or 3 packages where you're like, I have no idea. No, now it breaks. The previous version didn't break. I don't understand this code. The maintainer just communicates only by email. I can't file a bug report with this maintainer. It's a nightmare. And it's like a little check, but that can easily take like 2 to 3 weeks, right? The rep dev check.
That's a lot.
Yeah. There's a question there in the back.
Any comments or suggestions in terms of how you distribute your time with open source software development, maintenance, and your other research activities?
Yeah. So lately, I've been really lazy and on the software development, and there's like tons of stuff that I should be doing on Cowplot and other packages that I haven't done. So for me personally, like my research lab comes first, right? My like funded grant, if it's a grant funded research project, I need to meet my milestones and do my deliverables, right? I need to show up for my classes. I need to show up for my graduate students and so on. And then if I have time left over, then I can do software development. That's sort of how I approach it. And then it's also, my work tends to be very episodic. Like for 3 months, I'm really into doing something, and then I'm not, which I've learned is actually really bad for like open source software development. So I have the wrong personality to some extent. Like for me, it's really fun to, I have a new challenge like this Isoban package, and I figure out how to write the code that can do this fairly complicated geometric calculations. And that was fun. But now maintaining it and just making sure it never breaks as like the architectures change and so on, like that I really don't enjoy. And that's also why that particular package at some point, it was actually like this event where I was on holiday where I said like, POSIT guys, can you just take ownership of this package, right? I don't want this responsibility. So I'm not good, but that's just my personal thing. Like I'm not good with indefinite commitments. I'm much better with like the scientific approach of we do a project, we write a paper and we don't think about it anymore. That works much better for me. And so like we have to be aware, right? Like if you are also another reason why maybe you want to work on somebody else's project rather than be in charge yourself. If you're in charge yourself, you'll like get bug reports and issues and the most inopportune moments, right? Like just when you're on vacation, somebody releases a new compiler and suddenly your code does not compile with the new compiler, comes totally out of left field, but it actually needs to be fixed. And now you're like, okay, I thought I was on vacation, but now I'm fixing this. Like, it's my hobby project, but I'm doing it while I'm on vacation because otherwise there's 10,000 people that can't do their work. So it's a big commitment, and like, are you ready for that? Right? I'm not necessarily. So I'm very happy to give stuff away. You know, like I don't need to be the maintainer of 20 packages.
Any final quick questions?
Thank you. So I'm pretty new to this space, so I'm not sure if this is kind of the right question, but I guess in terms of getting started and gaining credibility, when you're trying to file bug reports and gain that credibility, is there any strategy you can take for that? Because I feel like oftentimes issues or tends to be a little daunting. So are you sort of like on the prowl for bugs, or is there any place to look?
So I don't think like you should file the bugs that you encounter yourself, right? Don't just search for bugs deliberately. I don't think that's a useful practice. But you can like monitor the issue boards and just like the first step would be you see things being filed and you're like, I think this is going to be the response, and then just see whether you can predict what more experienced people would respond, right? And if you're more often right than wrong, you can maybe just start like participating, right? What I did with ggplot, which I don't think is a thing anymore thanks to ChatGPT, but like 10 years ago, we had Stack Overflow, right? And for a while, I would just like try to answer as many questions on Stack Overflow as I could. And so that's lower stakes because I'm not in the ggplot issue tracker. I'm on this completely separate site, right? And I can just like gain experience. People have problems and I can say, okay, can I identify what the problem is? Like 9 out of 10 bugs are not bugs with the code that the bug is actually filed, right? Like 9 out of 10 ggplot, like bugs that get filed on the ggplot website are actually user mistakes or are bugs that are outside of ggplot. So for example, like R has this concept of a graphics device. Like every time you make a plot, in the end, it's drawn by this thing called the graphics device. In ggplot, we just send our instructions to the graphics device and it does its thing. And there's like 20 or 30 different graphics devices, like the device that writes to PDF, the device that writes to PNG, the device that like makes interact or like shows Windows on a Mac and shows Windows on Windows. And like the Windows graphics device is totally broken. And so like, there's like a whole class of bugs where people say, I'm running this code, I'm getting this garbled output. My first response is, you're running Windows, right? And then they say, yes. And then I say, it's your graphics device, right? So many, but you need the experience. How do you gain experience? Again, Stack Overflow, I don't think people do much anymore, but it's a good place if there's still activity, right? And the other is just like wade into the waters very carefully and like try to make contributions where you feel very confident that the contribution is correct and useful, right? Somebody files a bug and you say, that looks like a duplicate of this other bug. If you're consistently wrong, then maybe you're in the wrong field, right? But if you're more often right than wrong, then probably over time you're like gaining the right experience and the maintainers will actually be thankful. Okay.
Great. Thank you so much. Thank you for spending some extra time to answer those questions. That's really, really helpful. And thank you everyone for attending today. I think this was a really great event. The event was recorded, and would it be okay if we post this online as well?
Yes.
Fantastic. All right. So we will plan on making this available from our open source program office website. That's opensource.utexas.edu. And thank you again, everyone. Really appreciate it.